Okay, hey everyone. Thanks for joining us for Lido's fourth community call. We have a packed agenda today, so we'll try to go through this as quickly as possible. I'm Izzy. I'm a Lido DAO contributor working in the node operator management team, and I'll be your MC for this session. I'll just go through really quickly the agenda. So we're going to start with a quick rundown, a PSA, if you will, by Cadmill, who is another Lido contributor, towards the Lido
Recording in
node operators,
progress.
about the expectations for the upcoming weeks for testing Lido v2 on Gurley. Next, we're going to have a deep dive by Kirill from the tooling team, who's going to go into the Lido on Ethereum validator exits tooling, and all of the tooling and modules, open source, of course, in nature, that the tooling team has put together to help Lido node operators automate to whatever extent they feel comfortable the validator exits processes. And then we're going to have guest appearances by Attestant, who are going to present the upcoming vouch update and tell us a little more about what that's going to offer to node operators. Metrika, who are going to show us their new MEV Boost Relay Dashboard. Simply Staking, which is a Lido node operator, who will show us their open source Ethereum block proposal monitor for stakers that you'll be able to run at home. And RockLogic, aka the creators of Ethereum, who will show us SyncLink, which is basically a tool to allow you to more easily and in a decentralized manner sync both your consensus layer nodes and hopefully soon even execution layer nodes. So transitioning to the first segment, Cadmill is going to give us the quick PSA towards Lido node operators. Cadmill?
Hey, thank you so much for joining today. Just a second, I'll share the preview. So, with Chapella closing by, we are preparing for Gurley testnet. And for one of the largest upgrades we're done, we want to make sure everything works as smooth as possible. So I wanted to share a short outline of what this testnet run would look like. We have preliminary timeline, and basically first week of March would be devoted to preparing everything on the Gurley, with contracts and deployments and internal checks. And starting with 7th of March and then until Gurley undergoes Chapella, we would be testing, onboarding all the teams, checking everything is ready, giving all the Lido node operators deposited validators, and looking that both new and old link works in parallel and could be run and prepared for the hard fork. And the biggest thing here would be obviously for us to look for how the protocol works and how the protocol undergoes the hard fork itself. After Gurley would have Chapella, and till about 1st of April, we would be focusing on testing out how reward scheme works, how withdrawals work in like heavy path conditions, including injecting validator to test out all the tooling and all the ejection setups node operators would have. We would want to test bunker mode if you if that's the first time you hear those words together, please check out last Eugene's presentation on V2. We would want to test out modes of delayed keys injection and look for testing out other failure conditions in safe like waters of Gurley testnet. So there's that. Please stay tuned for onboarding news. Most likely we would have more detailed timelines by the beginning of next week. So somewhere by 20 February or 1st March. And so, yeah, stay tuned. Thank you so much.
Thanks,
Okay,
so now we're just going to have Kirill set up his presentation and then take us into the deep dive on the tooling that Lido contributors have created around validator exits.
Okay, let me share my slides.
It should be enabled.
Can you hear me well?
Yep, and we can see it. Looks good.
Okay, cool. Hello, my name is Kirill, and I work on tooling at Lido. And today I want to talk about the tooling for node operators version 2. First, I will tell about the scope of changes, then I will mention our schedule, and then I will go through some technical stuff. And it's okay if you don't get it at first. It took quite a long time for me to understand all the technical details. And of course, feel free to ask questions at the end. First scope is withdrawals. And as you know, it's the big thing for Ethereum, and we should be prepared. The second scope is a staking router, and it's basically the load balancer for a stake. If you want to know more about staking router, you can watch previous node operators call recording. So withdrawals and staking router are the brand new tooling. Sometimes, we all have deadlines that seems impossible, but it's a deadline and it's unmovable. Our schedule is the same. We have a girly testnet in the mid-March and mainnet launch somewhere in the early April. So timelines, as you can see on the picture, are quite tight. And going to the next slide. It's important to use the right tools to do the right job. So what we have here, we have two new tools. One is called KAPI and one is Ejector, and two pretty big updates, Oracle V2 and DSM, which stands for Deposit Security Module. First, let's talk about KAPI. KAPI is to serve information about keys, validators, and other data for tooling services like Ejector, Oracle V2, and DSM. KAPI periodically grabs the snapshot of the data from execution and consensus nodes and keeps this snapshot nearby. It's worth mentioning that KAPI consensus node connectivity is optional and can be disabled if it's not needed. KAPI in this case will serve only keys information. And getting all the state from Ethereum can take a while. And moreover, in case of using third-party services, it can cost a penny. KAPI helps us with that, since blockchain data is fetched by KAPI from Ethereum nodes. It's stored internally to be quickly served via REST API interface. And also KAPI is designed to support staking router and staking modules. And monitoring is crucial for KAPI. If it's not good if KAPI suddenly stops receiving new state from Ethereum, because obviously it will stop other services connected to it. Therefore, it's pretty crucial part of the whole system, and right monitoring is necessary. Good news, there are Grafana dashboards carefully handcrafted for you in GitHub repo, and you can take them, use them, and improve them if you like. And the next thing, the ejector. I think the great slide. Let's talk first how node operators should manage validator exits. A node operator should constantly monitor specific event called validator exit event emitted by the Oracle and respond to it. Respond by manually making voluntary exit call to consensus node, which is with a specially prepared exit message for the validator. It sounds pretty easy, however, this event can be triggered anytime, 24 hours a day, 7 days a week. And the ejector is here to make the node operator's life easier. Node operator just load a small batch of pre-signed exit messages into the ejector, and that's it. If the user wants to withdraw and the protocol buffer is empty, the protocol will emit event and it will be handled by the ejector. Super simple. There are some technical details here about the ejector. It will need execution and consensus nodes and a bunch of pre-signed exit messages. Pre-signed messages can be created with public and private keys of validators with tools like ETH2 and other tools. Public keys of the oldest validators can be obtained from KAPI. So to summarize, node operator should first prepare a batch of pre-signed messages, push this batch to the ejector, restart ejector, wait until pre-signed messages will be used by the ejector, and then just repeat everything from the beginning. Ejector can be loaded with pre-signed messages coming from various tools and support messages that are compatible with generic message format and ETH2 message format. Also, you can build your own automatization to keep ejector working. And the right monitoring is also important for ejector, because if node operators delays validator ejection, protocol will handle it and ask other node operator to eject one of its validators instead of delayed validator. Good news, Grafana dashboards are also included in GitHub repo, and you can use it. Here you can see our oracles. First of all, I want to say that the Oracle v2 update is important only for node operators that run current oracles. So if you don't run Oracle, you can skip this update. And let's speak more about oracles. Current Oracle reports only protocol TVL. V2 Oracle brings TVL, handles withdrawals and reports of exited stacked validators. Plus, new Oracle supports staking router and designed to be extensible. Actually, new Oracle is not just one. It's two different oracles, small exit bus Oracle and big accounting Oracle. They are bundled in separate applications and can be deployed separately. To handle withdrawals and new features of staking router, Oracle on-chain reports got a lot bigger. And bigger means more gas for each report and each Oracle instance, and that is not good. To spend less on reporting in that case and to be extensible, we used multiple techniques, and I'm going to tell you more about them. The first technique is hash consensus. The idea is simple. Oracles now agree on hash of the data instead of saving large data on chain. This is the first, actually, gas economy strategy. The second technique is a multi-phase reporting, and current Oracle just sends full report in one transaction, and the latest report costs even more, while V2 Oracle will send multiple transactions, splitting big last report into chunks. And of course, this multi-phase report will only be made after hash consensus to keep all the data on chain. And the third technique is what we call fast lane. Each Oracle has its own number, so they have kind of ordering. And on each report, all oracles are split into two groups, fast lane group and group of remaining oracles. In a good weather, only fast lane group actually do their reports. The REST oracles does nothing, thus saving gas and transactions. Each report fastlane group is shifted to the right by 1, so oracles are rotated, and the oracle's order is checked on chain. This makes participation more predictable and equal. Let's talk about our small oracle. Couple words here. Exit bus oracle makes a decision what validator should be injected, and based on deterministic algorithm, emits the validator exit request transaction on chain. This event is immediately handled by the ejector, and he knows what to do with it. So that's it. Good news. Oracle v2 spent less gas on consensus. Bad news. They now require a Hive execution node which is bigger. Because correct calculation of protocol TVL after withdrawals error is only possible when looking at historic data, and only a Hive node can provide it. There are different execution clients with different capabilities and options regarding archive data pruning. Oracles will just need up to 7 days of historic data. Everything older can be safely removed. Nodes compatible with history pruning are Rigon, Besu, and Nethermind. So you don't need to store the whole history because it's quite huge. So summing up, previously every oracle paid a lot, and the last one even more because of the report finalization. Now everyone pays less, and the participation is made more predictable and equal. A few words about deposit security model update. New version is designed to support staking router and can individually pose each staking model independently. That's actually all the updates for DSM. And that's all about the tools. As you can see, a lot of things changed, a lot of things left to be done and deployed, and schedule is tight. There will be readmes, manuals, Docker composes, and what to do's in testnet and in what order. Plus, there will be a team of DevOps rangers who can help with some technical issues. That's actually all from tooling team for today. Thanks for coming. Now, questions time.
Thanks a lot, Kirill. I see we also already have some questions in the Zoom, so maybe we can also talk about those. But I did have one question. If you can scroll back a little bit to the slide that was talking about the exit bus and the validator exits policy, or rather, it's a comment. So thanks for including the QR code about the draft proposal for the validator exits policy. So node operators and DAO community members, and of course, the wider Ethereum ecosystem is welcome to review the policy and provide any comments and discussions. The policy is going to be discussed for at least the coming weeks. Tomorrow, there is a deep dive session where the intent is to go over all of these tooling modules in detail, as well as how they tie into the policy. If you're interested in attending this session, please DM somebody from the forums or a Lido contributor from the Discord, and we'll share the Zoom link. It's just difficult to share Zoom links in public, but the intent is that the session will be open to anyone that's interested. I had one small question around the ejector module. We're talking about pre-signed exit messages. Would it also be possible to generate these messages on the fly instead of them being pre-signed?
On the fly, wait a second. No, they should be pre-signed in current implementation. I mean, the ejector awaits the messages to be here in the file, in the folder, right nearby injector, and maybe there will be some implementation for, I mean, other implementation, but now it's not.
Okay, understood. And if there were to be another implementation, is that something that we anticipate to happen via like pull requests from the node operator community? Is the expectation that the tooling team will develop this later? How are we thinking about this?
We need, I think, to understand what's most usable way to automate this. I mean, most usable and most useful and handy way to do that, because there is a security concern about that. We can't just put all presigns into the ejector because, like, if it's for some reason hacked or broken or something, we don't want to be in situation where all the validators just pulled out. So we thought about small batches of presigned messages. So we need to discuss this, I think.
Yeah, that makes sense. And I'm guessing, so technically you could pre-sign X amount of messages depending on what the key API is telling you. But if you want, you can ignore what the key API is telling you and just sign them like on the fly, like just in time, and then technically store them next to the ejector like right before you need them. So technically they're pre-signed. The ejector doesn't know how long ago they were signed, right? Or created, but it just knows that they're ready for it to be used, as opposed to the ejector actually initiating the request for the message to be signed.
Yes, the ejector is initiating, and he will need the presign, and it doesn't matter when this presign was created. I mean, if it was a second ago, it's okay.
Yep. Okay. I see some other questions in the Zoom chat from Sergey. Sergey, would you like to ask the question yourself, or should I just repeat it?
It has been answered, so I don't.
Yeah, but I think it's great to repeat it so that the people listening on the stream can also benefit from this information.
Oh, okay. I am asking about Kubernetes. Can we run all the service in Kubernetes, and can you provide some tools for that, like Helm chart, for example? Yeah.
It's discussable. I think you should talk about that with the DevOps Rangers. We actually thought about Docker composes and maybe Ansible, some Ansible automation. And we didn't thought you will go this far, but it's discussable.
Yeah, okay, thank you.
I think another interesting possibility here is that like node operators come up with whatever they think is best and try to generalize that, whether that's Ansible or Docker or Helm charts. They make that available to the rest of the node operator community, and then of course I don't see why not Lego could consider grants for this.
Yeah, of course. I think we will contribute on toolchain on that part, because anyway, we want to test it in Kubernetes, and we should consider how it will be like hard and so on. So we will contribute, I think, if it will be successful.
Okay.
Uh,
Other questions?
Yeah, there's a question from YouTube. How often do fast lanes rotate in Oracle V2? Is it daily?
Fast lanes rotate depending on the Oracle. Accounting Oracle rotates daily, so one report per 1 day. Exit bus Oracle reports multiple times a day. It's about 4 hours, I think. I need to check the spec, but it's hours. not daily. So these times. Something else?
I don't see any other questions in YouTube or in Zoom. If anybody has a question, feel free to speak up. Otherwise, we can get prepared to move on to the next segment. Okay, thanks a lot, Kirill.
Thank you.
We'll hear more about this tomorrow in the deep dive session as well. So just a reminder, anybody that's interested in joining that, feel free to DM a Lido NOM contributor on the forums or in Discord, or I mean, you don't even need to DM, just ask us and we'll send you the link. So next up, we have Jim from Attestant. It's going to tell us about the new upcoming version of Vouch.
Fantastic. Thank you, Izzy. So yeah, worth doing a very brief bit of background on Vouch first, as some people may not be aware of it. Vouch is a multi-client validator. So what it does is it talks to multiple beacon nodes and works on the basis that, given the way that the beacon chain works and the way that peer-to-peer network works, is that there's no guarantee that any one single node will have the best view of the network at any one time. So Vouch is focused on security and resilience. It looks at information from multiple beacon nodes before it decides what to do, before it tests, before it proposes blocks. As a result of that, it's also a high performance system, very, very focused on providing fast operations regardless of the scale. So you can run it with one validator, you can run it with 1,000 validators, and it's designed to do everything it can to sort of provide the information it needs and the attestations and the proposals and the sync committees and similar, and get them all out as fast as possible and in a resilient way as possible. So reason for this chat is because there is a new version of Vouch that will be coming out in the next few days. That version of Vouch will be version 1.7. So what's coming in 1.7? First thing, and most important thing, is going to be full support for Capella. So Capella, as we know, has already been released on the Zhejiang testnet. It's coming to Sepolia next week. We expect to see it in Goerli a couple of weeks after that, and mainnet probably, I would imagine, 2 to 4 weeks after that. So now is a good time to have a release out. It allows everybody to plan upgrades, have the system ready, and be fully Capella ready. And that's roughly in line with a lot of the beacon node releases, a lot of the execution client releases that we're seeing at the moment. There's really a push to make sure that they have Capella ready releases out there, Shanghai ready releases on the execution side. As a result of that, we're working with those guys, making sure that Vouch will be able to run alongside them. Outside of the basic support for Capella, kind of the upgrade system, there are a few additional features that have gone into place. One of them is an upgraded execution configuration engine. So being able to define for your validators which relays they use, gas limits potentially, minimum bids, all that kind of stuff. Very, very useful. Obviously, looking at fee recipients is very, very important for multi-client systems. So you may have one version of Vouch that's running, it could have 10, 20, 30 validators. Those validators might actually be owned by different entities. Because of that, you need to define what relays they talk to, what their fee recipient is, all of that kind of stuff in a way that is both easy and also legible for you. You need to be able to understand this stuff. So there's been a rework of a lot of the pieces inside Vouch on the execution configuration to make that a lot more simple, a lot more easy. So initially, it's a fully hierarchical configuration. What that means is you can just set defaults, and those defaults will propagate through all of the validators being used. So, for example, you can set a bunch of relays. They're your default relays. Everything will use it, but then you can override. So you can say, well, actually, everything's going to use these 5 relays apart from these 3 validators. Those 3 validators are only going to use 2 relays, and those 2 relays may have different configurations. So being able to tweak and change things like that allows people to run vouch with a large number of validators across a large number of different configurations without needing to create a very large per validator configuration file, for example. So that allows a much smaller, a much more compact system. Obviously, that means it's more maintainable, easier to update, easier to change. One of the features that has come in, we've added, there's the idea of the minimum bid. Minimum bid is something that exists in MEV Boost, however, only goes, it's sort of like a single value. So you can set it once, and that then applies to every relay out there that MEV Boost may talk to. Within Vouch, you can have a per relay minimum bid. So it might be you say, relay X, I'll take anything half an ether or more. Relay Y, I'll take anything 0.1 ether or more. So again, you can change that. And again, those can be set on a per validator basis or a per group basis. As a result of that, it gives you, again, a lot of flexibility. This is especially the case if you're dealing with customers who potentially might want to be able to turn around and say, okay, well, I have a certain set of requirements, and then you have another set of customers who might have a different set of requirements. Obviously, as far as Lido is concerned, we have specific information on the required relays. We have specific information on the accepted relays. So again, being able to set all of that up pretty easily is very, very useful. So that kind of thing, again, very, very powerful. It's going to tie in with some additional work that we're doing. We'll start to actually provide ideas of what a min bid for each separate relay may look like. So that's sort of an up and coming bit later on. The other point of the reworked execution configuration is that we're focusing on the ability to provide a separate set of configuration items per Ethereum wallet or per account. So again, a lot of the stuff that we've built from ETH2 and upwards around the idea of wallets and accounts, all of that comes into play as well. So if, say, you have a bunch of customers, each customer has their own wallet, again, you can set information quickly and easily for each one of those. A new account is added to a wallet, it'll automatically pick up all of the configuration information. Configuration information is also dynamic. It is reread every epoch. It can also be retrieved remotely. So if you have, say, a backend database where you store this information, you can have a very simple daemon that just gets a list of public keys, and from that it will return their configurations. So that type of thing, again, very, very powerful, very easy to use, and gives you a lot of scale. Outside of execution configuration, again, though, sticking around MEV, we have improved our MEV relay interaction. So one of the things we didn't do in the past was verify bid signatures. So if you supply a public key with a relay, then we will verify the bids to ensure and make sure that everything is correct. We also do more detailed analysis of the MEV bids before accepting them. So previously, we'd look at a number of bids, accept whichever one was the highest. Now we do a lot more checking of them. We've seen instances in the past where bids have had a high value but been invalid. We can now pick that up ahead of time to make sure we don't accept a bid that could be invalid and stops us from being able to propose. We also group the same bid that comes in from multiple relays. One of the things we've seen more and more recently is that we're seeing more builders sending their bids to multiple relays. This is actually a very healthy thing for the network, because as we all know, the one thing that can go completely wrong with MEV is we fail to unblind the block. We fail to get the actual block back and the transaction list back from the relay after we've signed the header. If that information is with multiple relays, that increases the resilience of the MEV system overall significantly. So that's something that's really, really useful to see. Very excited to have that. And now that we've seen that, as you said, we can now pull that block, the unblinded block, from multiple relays. It gives us, again, a significant speed up. So one of the issues is it might be that a relay can return the unblinded block to us, but it might take 2, 3, 4 seconds. We have seen instances where these take a long time. If that block is in multiple places, then we'll always get it from the fastest. So that kind of thing, very, very useful. Outside of MEV, a couple of other bits. We have preliminary support for DVT technology, especially around the OBOL product. So we're looking at how we can work with them. A lot of that is slightly different in the we would pass signatures, but signatures are not necessarily valid because they're only piece signatures, you know, the signature of one of the participants rather than a complete signature, things like that. So we need to alter some of our checks and balances to make sure we understand we are living in a DVT world. So that's something that's in, again, preliminary work, but anyone who wants to run that, please do let us know how it goes. We have general performance improvements and bug fixes as always. And the other item actually that is of interest is we've added open tracing support. So we did have tracing support in previously, but it wasn't completely comprehensive. At this point in time, we've added in full tracing. What that means is if your instance of vouch is ever running slowly or not doing something you expect it to do, you can throw open tracing on. It will monitor every action. It will keep track of events and results and can give a really, really clear view as to exactly what is going on inside the validator. So it's one of those things that's incredibly powerful to have and to use. Generally speaking, you won't have it on all the time. You'll throw it on when you start seeing issues. That will start to tell us what's going on. In the past, it's helped us in our dev systems to pinpoint errors in certain beacon nodes where some might be returning slowly. It's been very, very useful for us as one of those areas where if everything does go a little bit wrong, you can dig in very, very deeply to understand. So that's the short set of updates. As we said, there's a whole bunch of little bug fixes and performance improvements and similar, but they're the headline features. We expect the release to come out probably within the next 48 hours. We're obviously pushing out ahead of the Sepolia Capella upgrade. So anyone running Vouch on Sepolia, you'll have an upgrade in time to put in before next Tuesday when we move to Capella there. And that is pretty much it. Thank you very much for your time. And if you've got any questions, please ask away.
Thanks a lot, Jim. It's amazing that you guys are managing to pack all those new features and still releasing in a couple of days. So I'm going to start with some questions from the YouTube chat. And then I see also that we have some hands up in the Zoom. So one question from the YouTube chat. Let's say hypothetically a relay wants to test its new relay code base. How to best test this with the new vouch, apart from waiting 48 hours?
Well, as always, all of this is open source development, so the system is there and running. Your issue is mainly going to be finding well, it depends what you want to test, right? If you want to test the Capella side of things, then if you're on the Zhejiang network, you can run it now. There is a Zhejiang Flashbots relay available, so you can actually have this set up and running today. You will need to compile from master for the next couple of days until we release 1.7.0, but it is available. Alternatively, you can run it on again the same code base, but you could run it on Goerli today. And if you run it on Goerli, then obviously you don't have Capella in place yet, but the new MEV relay functionality around things like MEV bid and min bid and similar, that will exist and will run automatically even against the current MEV relays. I mean, you could even run it on production, although if you're doing it to test out, I'd recommend you certainly start on a testnet first.
Okay, and a follow-up question. Not all relays are using the included MEV payout system. I'm guessing like include the payout in the last transactions within the payload. For example, Block Native and Manifold don't use this. Will Vouch support this?
Yeah, so the way it works is that when you talk to an MEV relay, it will return you the bid value of the proposal, and that bid value should be the ultimate funds that come to you, regardless of the mechanism. So you could be the fee recipient. It could send you, something in the last transaction. There might be transactions in the middle that send you funds, but none of that should matter. What happens is the bid value should still be accurate, regardless of the mechanism by which it's transferred. So yeah, Vouch will still work regardless of which mechanism there is actually used to transfer the funds.
Okay, so in those cases, because this is something that I've also seen in the MEV monitoring that we're doing in-house, is that the bid value at least seems to be somewhat misreported by the relay. The bid amounts aren't largely different, but it usually seems to have to do with transactions included in the payload that are from or to the proposer fee recipient address. And so, like, obviously, maybe the builder doesn't know that. Well, they should know that those transactions are within the payload that they're proposing. but perhaps the relay is not taking that into account in the bid value that it's transmitting.
Yeah, and frankly, there are bugs in the relays. The relay needs to get its act together and make sure it gets the value correct. There's certainly things that can be done there. What we do is we run an external process, something called the comptroller, which will work out the calculation itself and compare the min or the bid value that's been placed in the bid against what actually comes out of the block. So again, we can't do anything before the fact because we don't get to see the transactions. That's one of the things with the MEV Boost configuration, is that it is what's called a trusted relay system. We do have to trust that the relay returns us a block with the bid value that is stated. We can't do anything about that in terms of confirming it beforehand because you haven't got the transactions. We can't do anything after the fact because we unfortunately, once we signed it, we signed it. We can't do anything about it. But what we can do is account for it after the fact. So what we can do is we can use something like controller to keep track of how much the bid value was said and how much was actually transferred and make sure it marries up. There are a few cases where it's slightly out, as mentioned. I think that's just a case of the bid value calculation code needs to be tightened up a little bit on some of the relays.
Okay, that makes sense. Devs, please do something. Torsten, you've had your hand raised patiently. Please go ahead.
Thank you. Right. So I'll start by saying we're running Vouch in production for all of our Lido stuff. And if DevOps really is just working around other people's bugs, I can say that Vouch has never caused us issues. It was always our own stuff. So thank you.
That's great to hear.
The main thing I've heard from other node operators, and it also made us nervous, was, Jim, you're amazing, but you're one person. Is there another organization that has committed to carrying on Vouch if you lose interest or capability?
At this stage, no. However, Attestant internally has a number of other staff that are working away on bits and pieces. At this moment in time, they aren't working on Vouch, but they are working on various internal tools that we have and similar, and they are aware of the code base. So, if I accidentally lick a plug and electrocute myself or whatever, then I will be replaced by someone who is just as capable as I am. Currently working on other pieces on the code base elsewhere that you don't see, but there are people there. The other thing worth mentioning is that we are seeing more and more, not just inside Vouch and Dirk, but in other areas, we're seeing more and more code contributions come from node operators, from people doing analytics work, from people just using the underlying client libraries. So although Vouch as a top-end product has sort of my fingerprints all over it, there's more and more work that's being done under the hood, which, we're something we're very, very happy about to see. We mentioned things like DVT earlier. That's an example where, again, people like Obol have been working on some of the underlying libraries to provide that support. We've had more updates around, like we said, the analytics pieces and similar. So more and more that's happening. So yeah, if I did die tomorrow, I would be sad, but Vouch would be able to carry on.
That's awesome. Thank you. Thank you for that reassurance. So the second part actually has to do, the second question, I guess, also has to do with DVT. And I should do a disclaimer here. I'm actually being paid on a monthly basis currently by SSV Network, or kind of being part of their tech advisory council. Have you looked at SSV Network for integration with Vouch, and what were the hurdles there?
So SSV seems, from what I understand, and my understanding may not be complete here, but it seems that SSV and Vouch kind of sit at the same layer. So if you look at Obol and their implementation, it's a middleware. So what happens is normally Vouch talks to a beacon node. Instead, Vouch would talk to Obol in the middle, and then that would go and talk to the beacon node. Right. With SSV, it's a little different in that the SSV client sits next to Vouch and would basically do the work that Vouch is doing. Now, again, we've had various tech discussions. I believe, again, they're using a chunk of the underlying code base that is in Vouch. So think things like the underlying communications libraries and the cryptography libraries and similar, they're using that. But then because they are at the same level as Vouch, they're kind of doing a slightly different way around of doing things.
That's actually a really good point. Yeah. So I think the thing that's interesting, we might be able to take this offline. So you're right in that SSV is a validator client and Vouch is a validator client. So they're at the same level. I also know that Vouch is currently back-ending to Dirk and not any other method. And SSV are really keen on having multiple implementations of the DVT spec rather than just themselves.
Yeah, I mean, there are certainly options there. And again, I mean, we have had technical conversations with them. Again, I think there's been a few bits and pieces added into the low-level libraries to help support the SSV guys. You know, I mean, SSV, DVT, whatever you want to call it, the general idea of being able to take a single validator and break its responsibilities across multiple systems is very interesting, you know, to Lido if nothing else, but certainly, you know, that it has broad applicability. And you know, we're always happy to be involved and do that. You know, it's worth mentioning that Vouch can use local key stores, but it doesn't have full flashing protection and similar around that. It's one of the things on the to-do list, but it's a little bit of a chicken and egg situation in that no one's using Vouch for this because it doesn't support it. So we're not going to bother supporting it because no one uses it. You know, it's certainly something that is potentially of interest. Our concern has always been that we worry about anything that's not the highest security we can imagine. And so, you know, Dirk is there because it's the highest security we can imagine. We'd love to do something that is, you know, as secure but able to work with other systems. It's just a case of finding our way through and making sure we don't do anything that unintentionally or intentionally reduces the security, because ultimately all we're here to do is, you know, protect keys and sign things. Absolutely.
No, absolutely. Thank you. Thank you for that. And I feel reassured about the future of Vouch should you, and I'll put this very bluntly, die, right? Like that's always a concern. So thank you.
Absolutely. No problems.
Okay. I don't see any more questions. Thankfully, it doesn't look like such a thing is going to happen anytime soon, Jim. So glad to have you around for as long as possible.
Glad to be here.
Up next, we have Alvaro from Metrika, who are going to present us their new MEV Boost Relay Dashboard.
Yeah.
Oh wait. Okay. Well, there's a question, but we'll take it offline, Mateus and YouTube, and we'll get you the answer from Jim. Thanks.
All right. Hello everyone. I'm really excited to be here with the Lido community to share the Relay Dashboards and alerts we've developed with support from a Lido grant. So a little bit about me. I'm Alvaro. I've been part of the analytics team here at Metrika for about a year now, and I've been leading the Ethereum MEV research efforts. Here's our Twitter and Discord, where we share blog posts and insights from the analysis we do. Some recent posts were around OFAC and OFAC compliance and withdrawals. So yeah, highly encourage everyone to join and follow. So a little bit more about Metrika. We started in 2019, helping protocol teams guarantee the stability and security of their network. Soon after that, foundations asked us to provide our tools publicly to their communities. We currently support 6 protocols on our platform. We've got Algorand, Flow, Solana, Acceler, and obviously Ethereum. Most recently, we've been focusing on providing more transparency and insights to stakers, node runners, and developers across the Ethereum community. And we've also collaborated with node runners so they can maximize the rewards. You can check us out at eth.metrika.co. And before we get into the actual dashboards and alerts, I wanted to give some perspective of the current MEV environment and why and how we're doing all of this. So I'm sure a lot of you are familiar with the current MEV supply chain, but wanted to do a quick overview. The MEV supply chain looks a bit like this. There are searchers identifying the best MEV opportunities, builders who are creating blocks filled with those MEV opportunities provided by the searchers. And then we've got relays, which basically send those blocks from builders to the proposers, validators. This differentiation between validators, relays, builders, it's an implementation of proposer builder separation. So now, this current supply chain, we're going to focus a bit more on relays. So how do relays work? So conceptually, it's simple. Relays get multiple blocks from a variety of builders and then send the block with the highest value to the proposer. In order to actually have proposer builder separation, like I mentioned, only the block header is shared. Another important thing they do is validate the blocks received from the builders and keep track of validator preferences through registrations. The way registrations work is that validators need to register with relays periodically, and then relays need to process those registration where basically gas limit and fee recipient are set and make that available so that builders can build blocks accordingly. Builders then build those blocks, and relays need to validate and simulate those blocks, and then whichever relay wins the auction, then it also has to propose that winning block. So it's simple, but some things could go wrong. So why do we even want to monitor relays, right? So relays act as a trust layer. Builders trust the relays are not sharing their blocks with proposers and are acting in good faith when relaying those blocks, and validators also trust the relays will propose the block when they sign it. So it's important to ensure that this trust is maintained. A relay not performing its duties could lead to missed proposals, as we've seen in the past. And relay duties are in some cases resource intensive, so performance differs based on what's the underlying hardware. Relay performance could also affect how much rewards both builders and proposers get, since relays are the ones that filter relay and ultimately propose the blocks. And as you'll be able to see, performance can be different across relays, and it's not just limited to financial performance. So how are we going to do this? So in order to promote transparency, we've built a series of dashboards and alerts. So really anyone can monitor relay performance and get alerted if things aren't going as expected. So a bit more into how we actually do it. So the way we do it is we get bits and data from the relays through relay monitors, and relay monitors are they're open source on our GitHub repo, so everyone can go and see them, and are based on the one originally built by Alex Stokes. And their purpose is really simple. For every relay on every slot with a validator registered to that slot, it queries for a bit. We log latency of that request and save the bit or any error that might have happened in the process. The relay monitors are also geographically distributed so that we can get a really accurate picture of what's happening. After we get that data, we just process and aggregate that data in our data engine, and then we use it to power the charts and alerts. So this is the home of the dashboards, eth.metrika.co/MEV. And I'll give a quick demo of it. And I encourage everyone to go on now to the dashboard and follow along with me. So yeah, this is the relay dashboard, the home of the relay dashboard. Here on the left, you'll see other Ethereum network dashboards. If you wanted to, you could go through other protocols. And here on the right, on the time range, on this dropdown, you can see the different time ranges we support. So you can switch between like 1 day and 1 week. So on this first dashboard, you can get a quick view of the status of the relays. I wanted to highlight this relays online table. which shows whether a bid was received by our relay monitors and which block was that bid for. I gotta say this missed bid in red is not usually common, but it happens sometimes. And so everyone's clear, we only query blocks where there is a validator registered. So in normal operations, this should all the time be green or occasionally be red, but usually not an issue. And then other things we show are MEV blocks, both in terms of total blocks as a percentage of the network and over time, so you can get a sense of what's the MEV landscape. Gonna go now to the second dashboard we've built, operational performance here on the left. This one is more operational and more detailed. On this one, you can also, on this region drop-down here at the top, select different regions from the relay monitors we've got distributed. So we've got Europe, Asia Pacific, South America, North America West, and North America East, and then all regions, which is the aggregate order of all the regions. Wanted to highlight this bits missed by relay chart. It's similar to the relay online table, but over time. And just to make this clear, missed bits means that a relay monitor did not receive a bid for a slot where a validator was registered for a given relay. Like I said, it's not critical unless you see a consistent spike of missed bids for a given relay. And then just below it, you'll be able to see an aggregate table where we can compare the total missed bids over the registration, since not all relays have the same amount of registrations. And here you can see clearly that even with different registration, different total number of registration, the performance of the different relays are a bit different. So yeah, next chart I want to highlight is this bid validation. Here we validate and track any possible bid faults. Bid faults basically cause the loss of MEV rewards on that particular bid, since that block relay is not valid. And we validate three types of failures. First one is consensus layer faults, and this is basically when a bid does not follow Ethereum consensus layer protocols. So for example, if timestamp and block height don't follow each other, or if parent hash is not actually hash of the previous block, things like that. So in normal operation, this is how it should be, this chart, nothing. If you see something, then keep an eye on, monitor, and maybe modify the relay list if required. Next one I want to highlight is latency. So latency is the round trip time in milliseconds for the actual bid query. It's interesting to see the differences across the regions, and you can select at the drop down at the top the different regions. And I would encourage node runners and validators to prioritize relays with low latency on the regions where they operate. And why is this? Because latency affects MEV rewards. And the first reason why is that MEV Boost or Vouch could time out. And that means you'll lose the bid for that relay. And maybe that's not the end of the world, but you're eventually going to lose MEV rewards. But even if you don't time out, relays with high latency will take longer to send bids, which could result in lower MEV rewards. So something to monitor and track. And right below the overtime chart, the line chart, you can see a table with some summary statistics of the measurements. And right below it, we've built a registration heat map. And registrations are a very resource-intensive task for relays. And we've seen issues with lack of confirmation when a validator is registered. Validators don't know if they're registered properly. So we wanted to bring more transparency into this. So hopefully this chart does that. With this chart, you can see if any big drop in in total possible registration happens, then something's wrong. And to clarify, this chart basically takes total possible registration. So for any given period of time, what's the number of blocks? And then for that number of blocks, how many of those blocks did that really have a validator registered? So you can also, as a side note, you can also see which one is the relay that almost everyone's registered to, and then what's the difference with other relays and any possible changes over time. Third dashboard I wanna highlight is economic performance. With economic performance, we wanted to show rewards distribution, and the idea with this, or how we envision validators or node runners could use this, is by setting min bid. Like Jim mentioned, Vouch now can allow you to set different min bids per relay. MEV Boost doesn't. So we've shown both an all relays aggregate and a distribution by relay. So you can decide and set min bid accordingly. So now I wanna explain and demo the alerts we've built. To go to the alerts, just click on the alerts menu, and then go to subscriptions. You'll see if you click on relay alerts. Oops. Let me try real quick. Looks like we're having problems. Yeah, so I'll do a go back to a presentation and just go over the alerts we've built. Let me go over a summary of the dashboards first. So on the dashboards, like I said, 3 dashboards. Relay overview, you can get a summary and overall stats of the relay status, operational performance if you want a more detailed view, and then economic performance, which could ideally help you set min bid. So the alerts we've set are 4 consecutive missed bids, which is triggered when a relay misses 3 consecutive bids, where there was a validator registered. Relays, occasionally do maintenance, so occasionally missing bids is not a sign of something going wrong, but definitely if this triggers, keep an eye on it and monitor. Second one is bid fault. We're basically we're gonna alert you if we see that a relay is relaying bids with faults. And faulty bids, like I said, are basically invalid blocks. So this will basically result in the loss of any MEV rewards. Best case scenario, if this happens, you can default to your local block. Worst case, you could miss the proposal. The third alert is around relay latency. And latency is going to trigger whenever a relay experiences increased latency. This could affect MEV rewards. Like I said before, there is a timeout when requesting bids, and even without triggering the timeout, high latency will take longer to send bids. So it could result in lower MEV rewards. In this case, the threshold we've decided is median 30 days to 1% across all regions. So anything over that threshold is really unusual and should really be tracked. The fourth one, and probably the biggest one, is intended fee recipient. This one is going to alert you if a relay is not or has not sent MEV rewards to the intended fee recipient. This is a big one because it breaks that trust that we've talked about. You as a validator are trusting that relays will do their duties, and this goes against it. So definitely keep an eye on that, and maybe even modify your relay list if this happens. And then in terms of subscriptions for the alerts, we support PagerDuty, Slack, Ops Genie, Discord, and Telegram. So you'll be able to configure any of those, or just regular email if you prefer that. So yeah, And then in terms of some next steps for everyone, definitely visit our dashboards and create an alert. Subscribe to, I would say, all relays at eth.metrika.co/MEV. Join our Discord. Happy to hear what the community is thinking. Any feedback is always welcome, and help us shape what we can do next. And we'll be at ETH Denver, so definitely stop by our booth, and we'd love to meet in person. And then I'll be happy to answer any questions.
Yeah, thanks a lot, Alvaro. That looks really great, especially also the increased insights in terms of the geographic latency, depending on where you're running your validators out of, and also the increased kind of exposure, let's say, to the kind of faults that may arise, where they might come from, and how many of them are happening to the relays across time. So one question that I had is, so let's say you're a node operator, right? How can you start using this? Just by following the link that you mentioned at the end?
Yep. Yeah, let me go back to it.
So app.metrika.co/ eth.metrika.co/MEV. Okay, that's great. And you can set up to monitor as many validators as you want. How does that work exactly?
Yeah, let me go back to it. Seems like it's working right now. Yeah, so like I said, click on alerts, subscriptions, and then you'll see the 4 alerts. And then you can click this button here on the right, edit. You'll be able to toggle the alert, click as many relays as you want, even all of them. I would, honestly just recommend all of them, and save the alert. And then you can also go into home, where you'll be able to see some summary statistics here at the top, relay alert summary, any 24-hour notifications, 7-day, your total subscriptions. And then if there were any firing alerts, you'll see them here. At the bottom, you'll see the summary table where you see different relays and why and which alert triggered, some extra information, and some timestamp about when it cleared, when it fired. And then just quickly, if you want to set up, let's say Telegram or Discord instead of email, just go here at top, user information, click on settings, and here you'll be able to toggle between different services: Telegram, Discord, Slack, whatever you prefer.
That's amazing, and anybody can use this, right? It's open to everybody, right?
Anybody. Yep.
That's really
You don't
cool.
even need to run a validator, nothing.
Okay, that's great. And I remember that so you guys are developing part of this, or at least you got input from Lego, which is the grants arm within Lido,
exactly,
about possible features that node operators were looking for. And part of that grant is that Lido node operators will get to use this for free for the next 6 months, but any node operator that is a small node operator, so anybody running less than 5 validators, will be able to access this for free indefinitely. And so that's a really, really cool thing on your guys' behalf to support node operators in terms of setting up automation and alerts for their home setups. I see some questions in the YouTube chat already, so I'm just going to go ahead and repeat those. And if anybody has any questions on the Zoom call, please go ahead and raise your hand. So Lawrence from the chat has a bunch of questions. What is the reasoning behind having bid faults less prominently shown than missed bids? A missed bid could just be that builders didn't have a bid for that slot.
That's correct. There's no particular reason behind it, but we'll definitely look into switching those and showing bid faults as the first chart using. Yeah.
Okay. The next question is there a delay on the alerts? And if so, how long is it?
The maximum delay you have is 1 minute, but yeah, that's the.
Okay. How do you get alerted? I guess this is kind of what you covered earlier, but it looks like you guys have a plethora of options, from Discord to Telegram to email to Slack, and PagerDuty and OpsGenie, right?
Exactly. Default is email, but if you don't like email or prefer other service, we're happy to send you the alerts wherever you like it. Yeah. just need to configure like I showed, you know, at the top settings, and then just choose whatever service you want.
Okay, awesome. I don't see any more questions in YouTube for now, or in the Zoom. So thank you, Alvaro, very much for the presentation and the great work that you guys have done on this. I look forward to also the write-up that you guys are going to do. And more possible collaborations in the future, because this stuff is definitely sorely needed, and I can see node operators getting a lot of use out of this. Thank you.
Awesome. Thank you.
So next up, we have Francesco from Simply Staking, who's going to present us their work on ETH block proposal monitor that stakers can run.
Hello, give me 1 second while I share my screen. Let me know if you can see.
Yep.
Okay, great. Hello, my name is Francesco, and I'm a DevOps engineer at Simply Staking. We're an infrastructure provider and validator on Ethereum. Today, I will be presenting a tool that we developed. It's called the ETH block proposal monitoring tool. So, the tool is written in Python and comes paired with a Grafana dashboard template. Its main function is to check block proposals and alerts whenever a proposal is missed or an empty block is proposed. It has several other functions that have since been added, such as validator sync community participation and rewards generated per block. However, in this presentation, I'll be focusing mostly on the block proposal part, since this was its original purpose and is its main function. So the tool gets the data that it requires from the endpoints of relays such as Eden, flashbots, etc., and a beacon chain node. So it keeps all the data that it needs and extracts information in the form of Prometheus metrics. These are then created by a Grafana dashboard, which we include in the repository. The code is lightweight, it's open source, and can be easily hosted by any validator of any size. So the tool was originally developed because we needed a way to be alerted whenever a block was not proposed properly. We did not find any suitable tool, so we decided to develop a simple one that fits our needs. So the tool only requires two main things to work properly. So it requires a comma-separated list of the public keys of the validators that will be monitoring, as well as the beacon chain activity endpoint. The consensus client of this endpoint can be any client as long as it supports the beacon node API spec. And optionally, for reward calculation of non-relay slots, an execution layer or an ETH1 node is required. We can get the reward value of slots that are relayed from the relays directly. However, for non-relay slots, we cannot get this information from the beacon chain node, so we need an execution layer node. So we'll go over the process of how the tool works very quickly, and then later on I will delve in a bit deeper into each step. So the tool constantly performs its functions and then sleeps for 20 seconds. It first gets the slots from the relays and non-relay slots using the beacon chain node. Optionally, using an execution layer node, we calculate the rewards of non-relay slots. In the case of missed or empty, in case of a missed or empty slot, the tool checks if the proposer is one that is in the list of public keys. If there is a match, so if the proposer is one of the validators in the list, the corresponding Prometheus metric is updated accordingly, and if configured, Grafana will trigger the alerting service used, and you would receive an alert. So the tool stores all the required data throughout this process in an SQLite database, so that on the next iteration, or if, for example, it is restarted, it can continue where it left off. So getting slots. So I will explain a bit this step in a bit more detail. So the tool first gets the slots directly from the relays. So by default, it gets the last 100 slots relayed by each relay, and then it uses that to construct a list of the last 200 slots on the network. So let's imagine we only want to get the last 10 slots on the network. So we query our list of relays for the last 10 slots, and we have 3 from Flashbots, we have 2 from Eden, and we have another 2 from Block Native. So if we combine them all together, we get 7 slots, which means we are missing 3, which were not relayed. And this is where our beacon chain node comes in. So here the tool queries the 4 slots that are missing in order to fill in the gaps. So during this stage, if we are monitoring rewards, we would also query the execution layer node for the same slots in order to calculate the rewards. As I mentioned previously, relays already give a reward value for each slot, so we don't need to calculate for relay slots. So with these 3 other slots, we have a complete list of the last 10 slots on the network, and we can proceed with checking and alerting. So with our list of slots, we can check if they are missed or empty. So relay slots are generally okay, as long as they have a reward value. They cannot have a reward value and be missed or be empty. There must be transactions in order for the reward value to be greater than 0. That leaves us with the 3 slots which were not relayed. So any slots which cannot be obtained using the beacon chain node are considered missed, and those which are obtained but their transaction is still empty are considered empty. So in these 2 cases, the tool checks if the proposer was one of the validators it is monitoring, so one of the validators in the list you provide to it. And if it is, the corresponding Prometheus metric is incremented accordingly. Then on Grafana, we have 2 panels which have an equation that monitors an increase in the missed or empty block proposal metrics. These are paired with an alert, which triggers whenever there is a missed or empty block proposal in the past 10 minutes. In the next few slides, I will be showing you the Grafana dashboard that I keep mentioning that comes with the tool. I will be explaining a bit the panels. So on the top left, we have a panel that shows the total number of blocks proposed by the validators we are monitoring through each relay. These are from the point the tool was started onwards, so we cannot get historical data. Then we have the number of blocks proposed in the last 10 minutes by our validators, again, per relay. This is the same thing, but in text form. Then we have the blocks proposed per validator with a public key so that we can troubleshoot if needed. Over here, we have the number of blocks proposals by our validators in the last 10 minutes, which were not relayed. And these 2 show the empty and missed block proposals in the last 10 minutes. It shows no data since there weren't any at the time that I took the screenshot. These are some statistics that are shown only if reward statistics are enabled. Again, reward statistics are completely optional and they require an execution layer node. These statistics are for the whole network. So not just for the validators we are monitoring. And again, they're from the point the tool started running onwards. So we have the number of blocks proposed, the number of blocks relay per relay in the last 24 hours, the average reward per relay, and the total reward per relay. Then we have just basically the same thing, but just for the validators we are monitoring. So we have the total rewards for our validators and the average MEV rewards for our validators. And finally, these are statistics regarding sync committee participation by the validators we are monitoring. So we have the percentage of slots that we participated in the current sync committee per validator. We have the number of slots that we did not participate in the current sync committee. And finally, I will go over very quickly through the metrics that the tool publishes and that you can make use of. So these first 5 are related to block proposals. They include the number of blocks proposed through each relay by our validators, the number of blocks proposed by each validator, the number of missed and empty block proposals by each validator, and the total number of blocks proposed through each relay. This last metric includes all validators, not just the ones we monitor. These are metrics regarding rewards. So the first 3 are the total rewards generated, the average reward generated, and the number of blocks with unknown rewards. They are all per relay and for the whole network. And the last 3 are the same thing, but just for the validators that we are monitoring. And finally, these 2 metrics are regarding sync committee participation. They are a count of the number of slots that each validator either participated in the sync or not for the committee starting at the epoch indicated. That was all that I had to say from my end. If you have any questions or feedback, please feel free. Otherwise, you can find our tool on GitHub. You can follow us on Twitter. Thank you for your time.
Thanks a lot, Francesco. I don't see any questions so far, but I definitely see a comment from Nikolai in the YouTube chat that says that they're already using it. It's a really great exporter. And they've integrated the exporter into a custom dashboard and alerter that they're building. So my question is, like, as a solo staker, how do I go about using this? What's the easiest way for me to set this up?
So it's quite simple to set up, and it's not very resource intensive. You might, if you don't have like a Grafana instance running already, you might run into some hurdles. But once you have Grafana set up, you just need to download the scripts and install the dependencies using Python, using pip. And then from there, you just need to provide it with the list, a comma separated list of your validators, or even if it's just one, just give it your validator, the public key. And then you just set up the config with the beacon chain endpoint. And once you start running the script, you should start seeing the metrics pop up on your local host on the port that you configure.
Okay, sounds great. And if anybody has any questions for you, they just reach out via your GitHub or Twitter, right?
Yes, you can reach out through Twitter. We have a very in-depth setup guide as well on GitHub. But yes, any questions, just feel free to reach out.
Awesome, thanks a lot. Okay, up next and the final segment for today, we have Dave from RockLogic, who's going to present SyncLink.
Sorry, can you hear me, guys?
Yes.
Yeah, sorry, because I did you also see? Can you also see my slides at the moment? Because I have your technical problems.
I can see them.
Okay, that's fine. Okay, then yeah. Hi everyone. First of all, yeah, thank you, Izzy, for the short introduction, and thanks to the whole Lido team for the invite. Yeah, as you can see on my screen, I'll be talking about SyncLink today, which can help you to sync a new big node fast and basically fast and secure. So before I go into this, a little bit about me. I'm Dave Sommer. I'm working at the RockLogic Limited. I'm there a part of the backend team from Ethereum, which is our flagship product in the Ethereum sector. And I'm also one of the SyncLink devs, the product that I present today. Yeah, so what's SyncLink? Or what's SyncLink in a very simplified summary? Basically, it's just a set of tools to sync your new Ethereum node. It consists of a SyncLink server, or of the SyncLink server, and the SyncLink client. With SyncLink, you can synchronize from everywhere. You can synchronize fast and secure, and it provides automatic checkpoint verification. So in a nutshell, with SyncLink, you have decentralized trusted checkpoints to sync your new Ethereum node. The last point is, in my opinion, an important point. So let me emphasize this. I said with SyncLink, you have decentralized trusted checkpoints, while on the other hand, you currently have more or less just centralized untrusted checkpoints. I mean, untrusted may sound a bit scary, and I don't want to scare anyone, but let's say checkpoints that you need to verify manually by yourself to trust them. I have this on an extra slide because people have asked me why they should use SyncLink, or what is the difference between syncing with SyncLink or syncing just from a checkpoint. And I think this is the main difference, yeah, and really important difference. Anyway, to give you a brief overview how SyncLink works, let's look at this diagram. On the left side, you see 3 existing fully synced nodes. Each node is connected to a SyncLink server, and on the right side, a SyncLink client and with a new beacon node that needs to be synced. It's not synced yet. So now, instead of synchronizing the new node from Genesis or from an, I call it untrusted checkpoint, it will be connected to the SyncLink client, which provides the most recent and automatically verified and therefore fully trusted checkpoint to the new node. I mean, the magic between this whole process happens between the SyncLink client and the SyncLink servers, because they basically negotiate on the best available point to synchronize the new node. So let's have a look on the current situation. So to understand the difference a bit more. So currently there are 2 possibilities to synchronize a new beacon node. Basically sync from Genesis. This is the default from all the clients, and you could synchronize from a checkpoint where the user supplies the starting state from a trusted source. It's in general more secure to sync from a checkpoint, and of course it's also incredible faster. But even then, if you sync from a checkpoint, you have to manually verify that the responded state of your trusted source is valid at all, because the source where you get the state from, maybe you trust the source, but the source could be corrupted, it could be hacked, or it could be otherwise invalid. So that's why you need to verify this. So yeah, how can you make sure that this won't happen? Or how can you verify this? If you really need to sync from Genesis, you can specify a weak subjectivity checkpoint. But this is a bit complicated. It's not the best practice, and it's usually, if anyone uses it, it's the last resort. Then you can, if you sync from a checkpoint, you can manually verify the checkpoint state root against multiple sources. You need to do this manually against multiple sources. And with both methods, you have to, you also, not you have to, but you should, and you can manually verify the final head block root against multiple sources. So with that in mind, let's summarize the current issues. Syncing from Genesis is slow and less secure. Syncing from a checkpoint of a single node is in general a single point of failure. Syncing from a single infrastructure provider is also a single point of failure, but it could be even more dangerous. I mean, dangerous is again a really big word, but how can I explain it at best? It's, I mean, it's an infrastructure provider is centralized, and because of that, it provides not just for a single user, but usually for tons of users, the infrastructure or that point to synchronize or whatever that infrastructure provider provides. And this is usually a good victim, or sorry, a good target for hackers, basically, yeah? Or as I have written, may a victim of different attack vectors. Yeah. And all three methods have one in common. You need manual verification, or manual verification is required. So if there are currently problems, the question is, of course, how to solve them, and or how to solve them easily. And you probably expect the answer from me at this point. It's SyncLink, or this would be at least make it much easier for you to tackle these issues. So let's adopt the previously that I mentioned in the beginning with those that I mentioned during my presentation. As said, SyncLink synchronizes from everywhere. You can specify multiple nodes and specify multiple infrastructure providers. So you don't have just a single point of failure with one node or one infrastructure provider. With SyncLink, you can synchronize fast and secure because the SyncLink server and the SyncLink client in cooperation always provides the most recent checkpoint to your new node. And the verification that I mentioned now several times during this presentation is done automatically. All this together is again decentralized trusted checkpoints, and there you can avoid single point of failure, and they are trusted due to SyncLink's consensus mechanism. It's basically works the same way as Ethereum consensus works. There we have, if you have one node, of course, or if you just sync with one node, you will not have you will not profit of SyncLink. But if you use 2, 3, 500 nodes, there is a huge difference, I think, in between SyncLink and a normal sync from a checkpoint. Yeah. So that was basically the theoretical part of SyncLink, and now I want to show you an example how this works in action. It's pretty simple to run this example. If you have Docker installed locally or on any of your virtual machines, for example, I would invite you to join the wiki, the SyncLink spec wiki, and there we have a short documentation how everything works, how SyncLink works. Basically, this what I'm talking to you in this presentation, and there you can download the SyncLink example YAML file, and you can run this in Docker, as I will do now, and it's pretty simple to see SyncLink in action and see if this basically an option for you. So now I need to give you a new window. I hope this works. I'm not sure about that, but I will at least try that this works, and I give you a shell window. Can you see that, guys? Can you see that window?
Yes.
Thank you. Yeah, it's just a short example. I will do it really quick. It's I post here the raw command for you. I'm here on a virtual machine. I have just installed Docker, nothing else, and I download the SyncLink example YAML from our wiki. And basically, I'm created here two data containers for Tico and BISO. I'm joining the example folder, or I move to the example folder. And then I run the Docker app sample. I just added here three nodes. So there are 3 different nodes that will now provide the best available checkpoint to, in this case, Tico. Of course, you can use any other clients for this example, as it's just an example. And it's really live now. So you see the Docker containers are downloading, and this takes a bit time. But I didn't want to provide you something that is fully prepared or anything. I did want to show you what happens. By the way, I also grabbed instantly the initial state now from Tico from the Docker logs. Yeah, that I forgot to mention in the description in the beginning. So the first things here, of course, is just the consensus client, and now it loads the initial state from SyncLink, and bam, there we go. You see initial state loaded, and at epoch, and so on and so on. So basically, you have now with this example, you have now a fully or almost fully synced node. I can show you this by calling the API. So this is called locally. You see, I call here, we have here installed Tico version 23. And yeah, basically that's really pretty fast. We have here 0 sync distance, so the node is basically in sync, almost in sync. I mean, that's really close. And that was pretty fast. Sometimes, of course, you can have a small sync distance there. Then just to show this also, you can just run these commands here. Docker compose down will shut down the example, and I clear here also the data directory and move out from the example directory. So basically, with these steps that I showed you here, you can run SyncLink and you can stop SyncLink, and you don't have any can I say, any trash on your system left or something. It's everything in the example folder, and everything is cleaned there. So yeah, basically, I can now go to back to my slides, and I hope you see them. Because I just want to show you as last part the GitHub repository. We have a wiki, and which is in the SyncLink spec, the SyncLink where we provide an information for both the SyncLink server and the SyncLink client. But both the SyncLink server and the SyncLink client, each of these has a separate repository. And by the way, you cannot only run this with Docker. You can also, it's the easiest way, as you have seen, hopefully have seen on my example. And it's you can of course run this without Docker, just with Python. Yeah, if you have questions after that meeting, I would be very happy if you we would be very happy if you call in, join our Discord, or write us an email, and or visit our website, or write me. You can also write me directly in the Discord. I'm Dave Rollo there, and sorry guys, I have here a bit technical problems. It was a bit, I was a bit confused during this presentation, but I hope you have something that helps you in the future to synchronize your nodes fast. So thank you, and that's it.
Thanks a lot, Dave. I actually have a couple of questions right off the bat. So obviously we saw this working amazingly well in terms of getting a synced CL node up and running in a few minutes. Is there plans to extend this also to execution layer clients?
There are plans, yes, but that's they're really far away at the moment, because at the moment I forgot this to mention. I'm sorry for that. We are currently in an alpha state, so it's a pre-release. It's an alpha version, and of course there's a lot of tasks to do to make it really stable. We also have several other plans for SyncLink and the current version to sync the beacon node. So I cannot give you a time frame when but we have plans. We have plans, and maybe we can talk with the client teams about that. But currently, the beacon node is our main priority.
Okay. And which consensus layer clients does this currently work with?
This I almost all. Sorry, I cannot tell you this now in basically with the major clients. So just give me let me make it easier. If you visit the repository, the SyncLink server or the SyncLink client repository, we have written there which clients we support and we don't support. So basically at the moment we support, but at the moment we support all major clients.
Okay, that's great. And so say I set up SyncLink. Obviously, I can use this internally, especially if I'm running nodes in multiple places for redundancy, right? If something happens to my node or it gets corrupted, I could very easily retrieve the state from other nodes, but do it also in a fault resistant manner, right? Because like maybe if I'm retrieving it from one node that's also corrupted, I would run into the same problem. But let's say I want to participate like in the wider SyncLink system, right? How does SyncLink find, let's say, peers from which to draw from, and how would I add myself as a possible peer to this list?
You mean a peer to basically a node to sync from?
Yes.
Yeah, at the moment, so at the moment you need this to specify manually. So there is a configuration file, and there you can add nodes that you might trust. As said, you can trust a node. That's one point. That's one thing. So I would not trust the node from anyone, but maybe if a friend of mine or someone of my family has a node, I can basically trust this node. But that doesn't mean that I trust the source or the response, the initial state that I get from this node. I still have to verify this. So your question points probably, is this done automatically? Can SyncLink provide automatically trusted peers or I guess this question points on that. And no, we do not provide this automatically, because who is trusted, who is not trusted, is basically not a decision of a client team or of a developer. It's of course your own decision who you trust. This is the first thing. The second thing is, if you want to add you to the peer, this answer is pretty simple. You just add yourself to the configuration file.
Yeah, thanks. So kind of what I was getting at is that this could be very useful if you have like a community of node operators that are like, let's assume that they trust each other, right? And so they can maintain some sort of like trusted peer list. But the point of it is that the more you add there, the less likely it is that you end up with something that that is corrupted or is like not correct, unless of course that list in and of itself or that community has been sybiled somehow.
The more you add, the more trust you have, of course. I mean, if you have one node, you don't have, you trust your friend maybe that it's valid. I mean, you always should verify in the end that your node is correctly set up and syncing probably and stuff. I mean, that's of course, but you can be much more confident with SyncLink. We provide, you can say, if I use SyncLink, I can be almost sure that everything is running fine after I did set up one node, 5 nodes, or maybe 100 nodes. And yes, you're absolutely right. If you have, if the providers, so great node operators or multiple sources trust each other, it's not the question if they trust each other, it's the question that SyncLink checks if the sources are valid. I mean, you would need a really large pool of invalid nodes that SyncLink would fail at this point. And of course, as much more providers, really great providers, trusted sources, client teams whatsoever, provide checkpoints for SyncLink to add this, or to add this that the users can add this, the more security or the more trust, or how can I explain this? I hope you understand what I'm trying to say.
Yeah, I understand. And the consensus mechanism you said that you use is like the same as Ethereum. So is it like 2/3 or is it simple majority or?
This also, at the moment, I guess we have added this 2/3, yes, or 50-50, or if more than, so if we have 3 nodes, if 2 are valid, then it's okay. But it's not that we decide this, it could be decided by yourself. It's also a configuration file. Maybe I should point this out a bit more. You didn't see this in the or I didn't explain that example during the presentation. The SyncLink client, the same as the SyncLink server, both have a configuration. You can configure it through a YAML file. You can configure it through the command line. And there are, of course, first of all, these options like adding the node that you think that are trusted. And also there are other configuration parts like how many nodes must be valid or how many nodes must have the same result that it's valid, basically.
Okay, like a minimum threshold. Really cool.
A minimum, yeah.
Okay, awesome. Thanks a lot for that explanation. I'm looking forward to this reaching a beta and giving it a whirl. Thanks a lot.
Yeah, thank you. And really, I invite everything to the repo and to our Discord. And thank you very much for the invite today.
Yeah, absolutely.
Okay.
Thanks. And with that wraps up the last segment for today. So thanks everybody for joining us for yet another marathon session. Our next community call is probably going to be sometime between mid to late March. It really depends on how things line up with Chapella. We're going to have most likely a lot of things to talk about as the V2 upgrade would be ready to go live sometime around then or a couple of weeks following, and results from initial testnet experience, and also a lot of other things that are being worked on in terms of like staking router modules, research and design on how Lido can increase its node operator diversity numbers and impact on the space in general. So thanks everybody for joining, and hopefully see you on next month's call.